Have you ever stopped to think how all the different apps on your phone just work together? We're about to pull back the curtain on one of the most important, yet totally invisible technologies that powers our digital lives, JSON. It really is the unsung hero of the internet, and we're going to break down its official rulebook, RFC 8259, to see exactly what makes it so special. Okay, so picture this. You pull out your phone to check the weather. Your phone is, say, an iPhone. It's reaching out to a weather server that's probably running a completely different system, maybe Linux. How in the world do these two totally separate pieces of technology, built by different people in different places, talk to each other instantly to tell you if you need a jacket? Well, the answer is actually kind of beautiful in its simplicity. They just agree to speak the same language, not English or Spanish, but a universal language made just for data. It's like having a perfect real-time translator that lets any app talk to any server, no matter how different they are under the hood. And that language, that universal translator, is JSON. It's the invisible grammar that gives structure to all that data zipping back and forth between your apps and the internet. Without it, our connected world as we know it, well, it just wouldn't be possible. Your favorite apps would literally stop working. So its official name is JavaScript Object Notation. But here's the funny thing. And this is the most important part. The key to its identity is being language independent. Yeah, it was born out of JavaScript, but its design was so clean and so simple that pretty soon everybody wanted to use it. Python, Java, C#, you name the language, it speaks JSON. So you might be wondering, how did JSON become this massive global standard? I mean, there were older, way more complex formats out there already. The secret really is in its core philosophy. It wasn't built to do everything. It was built to do one thing perfectly, structure information, and to do it with absurd simplicity.
You can see it right in the original design goals. It had to be minimal, like the fewest rule possible. It had to be portable, so it would work on any machine anywhere. Textual, which just means it's plain old text that you and I can actually open up and read. And finally, being a subset of JavaScript gave it a huge head start, because it was already native to the language of the web.
All right, let's get our hands dirty. We're going to pop the hood now and look at the actual pieces that make up any JSON message. And trust me, you're going to be shocked at how simple this really is. This is the key. Everything in JSON, from the current temperature to your entire social media profile, is built from just 6 types of values. That's it. 2 ways to group your data and 4 simple types of data to put inside. The 2 structures are objects and arrays. An object is just a collection of name-value pairs. Think of it like a dictionary entry or a contact card in your phone. Name is Jane. City is London. Simple. An array is even easier. It's just an ordered list of things, like a list of ingredients for a recipe or the forecast for the next 7 days. And what do we put inside those objects and arrays? Just 4 basic things. A string, which is just text. A number, well, that's just a number. A Boolean, which is a simple yes or no, true or false. And finally, null, which is just a way of saying, hey, there's intentionally nothing here. And this just brings that idea of minimalism home. The entire grammar of JSON is built using just these 6 characters. That's it. Curly brackets for your objects, square brackets for your arrays, a colon to connect a name to a value, and a comma to separate your items. That's the whole shebang. So you're probably thinking, okay, if it's this simple, why does it need a super formal technical document like an RFC? That's a great question. And the answer is to make absolutely sure that simple means the exact same thing to every single computer, everywhere on the world. The document's #1 goal is to achieve what it calls maximal interoperability. That's a fancy way of saying that if a programmer in South Africa creates some JSON, a computer system in Finland can read it perfectly, with 0 confusion. This rulebook isn't just a suggestion. It's a global contract that makes sure everyone's software plays nicely together. And here's a perfect example of why those rules are so critical. The rulebook says that names inside an object should be unique. Now, notice it says should, not must. But it warns that if you don't follow this rule, all bets are off. One program might read the first value you sent, another might read the last, and some might just give up and crash. The rulebook prevents that chaos. Here are 2 more rules that are absolutely non-negotiable for making things work. First, all JSON text must be encoded using UTF-8. This is what lets us use any character from any language, including emojis, and know it will show up correctly. Second, no byte order mark, or BOM. It's this tricky, invisible character from older systems that can really mess things up, so the rule is simple.
Just don't use it. Period.
Okay, enough theory. We've seen the building blocks, we've looked at the rules. Now let's put it all together and see what this actually looks like in a real-world example pulled straight from the official spec itself.
Let's just walk through this. See the big curly brackets on the outside? That tells us the whole thing is one big object. Inside, the first name is image, and its value is, look at that, another object nested right inside it with its own details. We've got name-value pairs like with the number 800 and title with a string. See animated? That's our Boolean value, set to false. And at the end, IDs is an array. You can tell by the square brackets. Just a simple list of numbers. It's all there, every building block we talked about, working together.
When you really step back and think about it, JSON's incredible success isn't some accident. It's a powerful lesson that sometimes the most complex, amazing systems, like the entire modern web, are built on the absolute simplest, most well-thought-out foundations. Those strict rules aren't holding it back. They're exactly what makes it so powerful.
And that kind of leaves us with one last big question. JSON proved that a simple, open, universal standard can completely change the world. So as we're looking ahead at what's next, AI, quantum computing, you name it, it makes you wonder, what simple, elegant, universal language will be the foundation for that next great leap in innovation?